Okay, so I'll be coming around to check worksheet 3 and 4. You should be working on our warm-up here. Now, a couple of reminders. When it says the congruency statement for the triangles, you're saying triangle yada yada is congruent to triangle yada yada. These are not right yada yada, but they're actually letters. And then it says list each of the congruent pieces. That means we have 3 sets of angles, 3 sets of sides. So we have 6 pieces are listed. So like side LN is congruent to side. Side NN is congruent to side. So that's what we're talking about there. And again, I'm coming to check homework.
Oh, I thought we were doing the
Okay, is there anyone's homework I did not check? Alright, so let's take a look at our warm-up. So today we have our quiz, so we'll go over homework questions, we'll go over our warm-up, take our quiz before lunch, it's a 20-minute quiz. Then we have lunch, and then when we come back, we'll have our lesson on isosceles space English theorem.
Yes!
Yes, isosceles space English theorem.
Is this?
No, after.
What do you mean? Are we gonna? Is this test like front page? Or
Why do you say test? That makes people nervous. Quiz. 1 page front back. So our quiz is over day 1, day 2 material. Last class we talked about proving triangles congruent. That's what your homework was all about.
It's not having the SAS or ASS stuff in it.
That was last class.
No, that was the whole point.
But day 1 stuff, we were simply identifying what it means to be congruent. And so we know when we have congruent polygons or congruent triangles, all the pieces are congruent. So that's kind of like number 1 here. We classified triangles based on sides and angles. And we had our triangle rectangle there.
Can we go over number 16 on worksheet 4?
Is that the one that has your guys' favorite triangle?
Yes, sir. Yeah, I really actually have a problem with that one. I'm not even gonna lie.
Yeah.
Why did I let that be on there? Okay, so first let's take a look at our warm-up.
And
You did this to yourself.
Yeah, you really didn't go. This is going to be something in the book.
So it says congruency statement. Make sure you read and follow the directions. We didn't have to prove that they were congruent, which if you did, there would be multiple ways to do it. But they want us to go ahead and list the congruency statement. And again, that's triangle, yada yada, congruent triangle, yada yada. So I'm going to go ahead and fill in my remaining information. I do know that these share that side by reflexive property. And also our third angle theorem says if I know 2 angles are congruent, then my last angle must be congruent. This will help you out when you're making sure you match up the letters correctly. So I'm going to go triangle LMN.
So how do we know the other side is?
How do we know what?
How do we know angle N is?
Because they already gave us the other 2 angles are congruent, so that our third angle theorem says if we already know 2 sets are congruent, then that last angle has to be congruent. If you think about it, it adds up to be 180. These are the same, so it's going to be the same amount left over from 180 for our remaining ones. Like if I had 140, and both triangles have 40 left over. Alright, so I went with LMN, and that's going to be congruent to triangle LON. Now please do a quick check to make sure that you have the correct pieces matching up. LMLO. Those are indeed the same. That's the 1 tick mark. MNON. Those are indeed the same. That's the 2 tick mark. And LNLN. That's the same. So please do that check to make sure that you have it in the correct order. Now it says to list each of the congruent pieces. Again, in triangles, we have 3 sets of angles, 3 sets of sides. You can either pull it from your picture or pull it from your statement here. Now, unfortunately, our picture has some shared vertices. So although I can say angle N and angle O, I can't say angle L because there's 2 different angles there. So I'm going to start off by listing my angles. So I have angle NLN. I have to use 3 letters for that. Is congruent to angle OLN.
Oh, we have to do that for everything.
For 3 angles. So again, because there's more than one angle half an L, you can't just say angle L because I don't know what angle you're referring to. Now, when I talk about angle M and O, that's the only angle there, so I can go and say angle M is congruent to angle O. That one's nice. And then we have angle M and L is congruent to angle O and L. Now, again, in our picture, we can see that it's shared. If they just gave us this statement, and it's 6 different letters, then that means that they're not sharing vertices. In our statement, though, here, we can see that they are sharing vertices. So when they share those vertices, you have to do those 3 letters. If they're not sharing vertices, you can just use individual letters there. All right, so that's my 3 sets of angles. Now let's write 3 sets of sides. And again, you can pull this from your congruency statement, LMLO, or a picture here. So segment LM is congruent to segment LO. MNON, segment MN, segment ON, and then LN, LN. And make sure proper notation, we have angles congruent, segments congruent. But these are the congruent pieces. We've got 6 pieces. Questions on that first? This was like the bare basics of congruency before we learned our shortcuts. All right, then number 2, classify each of the following triangles by their sides and by their angles. What are the 3 different ways we can classify them based upon their sides? Who can give me one of them? Sabrina? Scaling. I'm just going to write out. Good. What's another one? Isosceles. Good. And what's our last one?
Equilateral. Right.
Equilateral. Good.
Is your name Eden?
Don't sleep on that right one.
Interesting.
Hello?
Eden's voice sounded a lot like Spoon's voice. All right, so it's based on their sides. Eden, what's one based on their angles?
What?
What is the way to classify them based upon their angles?
See, no sleep on that right triangle.
Good. Yeah.
Yes,
got it.
sir.
Why'd you say like a question?
Yeah.
A Q. Henry, give us our last one.
Obtuse.
Good. Obtuse.
Yeah.
Okay. And keep in mind from our last unit, we learned if the angles are the same, the sides opposite are the same. Okay. What's my remaining angle for this first one?
50. Guys, I can't believe you didn't do that.
Okay, so what is this one based upon the angles?
Equilateral.
Twos.
Oh, I thought that was the same one.
James like,
And what is it based upon the sides? Scaling. Good. 3 different angles, 3 different sides. We do have an obtuse angle, so it's not just one.
so if there's just one obtuse, it's obtuse. If there's all cubes, it's a cube, right?
Yes.
It's crazy. That's
If
what
you see an obtuse, it means obtuse. If you see it at 90 degrees, that means it's a right angle.
and if I see all of them,
All a cube.
oh my god, that's crazy.
All right, now again, we know that when I have congruent angles, that means the sides opposite are going to be the same.
Equilateral.
Careful. So I know my third one's the same.
It's not equilateral. It's actually isosceles.
It's going to be isosceles.
Yeah.
It's isosceles.
You are terrible.
Can't. Did you even do this one?
Yeah, I did.
Oh.
Yeah, I had.
You have isosceles. So what is it based upon angles? Ooh, actually, that's a bad
cube.
example.
A
What does
cube.
it look like it is?
A
based
cube.
Yeah.
I.
Shh.
Don't sleep on me.
We should have had some actual numbers today.
Wait,
though.
why is it isosceles?
So I know that these 2 angles are congruent, which means I'll have 2 sides congruent, but I don't know that the third one is the same.
Same as the.
Same as
Oh,
these
yeah.
guys.
So,
Okay.
equilateral, all 3 have to be.
Yeah, equilateral all 3.
Right triangle.
Is this a 90-degree angle here?
Yeah.
Oh, how nice.
How do we know that? You can't prove. Oh,
Because
18.
it's 18
Yeah,
plus
yeah,
17.
yeah.
And what is it based on the sides? Scaling, good. Is it possible to have a right triangle that's equilateral?
Yes.
Good. So we have hypotenuse, what's straight the legs, equilateral, all three sides are the same. Also, what's the angle measures in equilateral?
No side.
Unless you add them in the negative angle.
No side.
What's the measure in equilateral triangle?
180.
They're all, what?
60.
They're all 60.
Oh, okay.
Okay, so the only other thing that we learned on that first day was that triangle exterior angle theorem. So just a real quick
So
refresh.
there's a
of that.
one dash mark on all sides of the triangle.
Equilateral. Alright,
Oh, let's
so,
see. Forget about the negative. Yeah, this is actually smart.
so remember our exterior angle theorem. Let's say this is 1, 2, 3, 4. If I tell you the measure of angle 2 is 50, and the measure of angle 3 is 70, what would the measure of angle 1 be?
Okay. One point, they're like 40 minutes. 100.
No, guys. It would not be.
It'd be 60.
So we want measure of angle 1.
120.
So my exterior angle equals the sum of the remote interiors.
120. I was thinking of angle 4.
That's what I figured. Alright. So what I would like for you to do is let's take a look at worksheet 3.
How about we look at the back side of the sheet? It would show.
Yeah, I'm feeling like that for 16 hours.
I was so fun. I remember saying that class too. I was like, if there's ever an angle or triangle with Joe, that's the best geometry day ever.
I guess it's the best geometry day ever.
I'm not cracking any jokes.
That's such a lie.
You want to put money on it?
I'm not putting money.
Alright,
I don't think you can live without cracking jokes.
worksheet 3. So again, make sure you follow the directions for worksheet 3. It asks for you to state why the triangles are congruent.
Could you just say
If-
yes for number 1?
Yeah. If they can't be congruent, right, not possible, and then you're writing the congruency statement. So again, congruency statement is this guy here. So we're writing which of our 5 methods and a congruency statement. And just a real quick refresher, what are those 5 methods?
Side, 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 side.
Side, side, side.
Side, angle, side. Side, angle, side.
Angle side.
Yeah. Angle, side, side.
Angle side, angle.
Almost side.
Angle side, what's start?
HL.
HL. And don't you dare
I almost
write a
got it.
bad word on any of my assessments.
H.
One be AAS.
Let's take a look and see. So for number 1 here, they only gave us that these are congruent, so we have side and side. Okay, so go ahead and double check these.
So garbage everything for that.
What did you say?
So bad at these.
That is not what you
It's
said.
like garbage at first.
Okay. That's what I thought.
Is the bottom right not possible?
Again, when you're on your congruency statement, you might have your letters in a different order. Just make sure A matches up with C, B matches up with B, D matches up with D. Do we have questions on 1 through 6?
Number 6.
Yes.
I wrote ASA, but how would it be AAS?
So if you did your alternate interior here and here, then that would be angle, side, angle, angle, side, angle. But let's suppose that you went ahead and did both sets of alternate interior, then you technically could do angle, angle, side, or angle, angle, side. So again, guys, just make sure your markings on the picture supports whatever method you use. All right, questions on our bottom ones?
Oh, how is 7? What did you say? What is that?
7 is side, angle,
Oh,
side.
yeah,
So
the vertical.
they gave us those words working right, and then we filled in the vertical angles.
Yeah.
And again, my biggest caution to you is make sure you know for sure that the markings you're about to put are true. If you can't justify it in your head, you might be assuming something that's not true. So like for number 8, Just because the sides look congruent doesn't mean that they are. So if you're about ready to mark that down, make sure you could justify it to ensure that it truly is true. All right, let's go take a look at the back side.
There's a lot of sass in this.
So you won't bring those.
I'm seeing there's a lot of that.
I feel like some of these look familiar, like they were on the notes.
They were.
Ugh,
Number 10 was definitely on the back here.
right? Because it had the different, like it looks different, but it's the same. All right, do we have questions on 9 through 12?
Oh, I got total brightness.
Oh, that's wonderful.
That's crazy. I also got it right.
All right. Number 16, technically, you would have only used angle, side. I used the isosceles base angle theorem, which you technically haven't learned yet, so pretend that it's not there. You do know the reflexive, so we have angle, side, angle, side. Later today, look at that one appearing again. Later today, we're going to learn about that isosceles base angle theorem, and that just adds another component of more ways to do it. All right, do we have questions on these?
You know, use the isosceles base angle theorem to use them.
Sure.
Yeah.
But after today, you really can use it. Okay. All right, worksheet 4.
Use it.
Yeah?
Oh, so you know what
But-
it is already?
No, you don't have to.
We can we?
Sure. Just make sure you mark it on the picture so that I know that that's what you're doing. Okay, now for worksheet 4,
I'm not taking it. I'm holding it back. Adam started talking to you.
now the instructions here, you didn't have to write the congruency statement, but they did want you to list what else you used. Now, a reminder, like the last one we did at the end of class, when we have this kind of bow tie overlapping, anytime there's overlapping, check any sets that we have. So we have to check first, or not first, but we have to check the bow tie, and we have to check our overlapping. Now, the sneaky thing here was not only did we have reflexive property and vertical angles theorem, but because they're both perpendicular, two lines perpendicular to the same line means that these two lines are parallel. Raise your hand if you caught that.
Which one?
Good work. For number 1, these lines WY and TZ are parallel. And so that allowed us to do a little more with like alternate interior down here.
Wait, how did you know that, you see the right angle, you see where the right angle is? How did you know those two angles are similar?
These ones down here.
Yeah.
We don't say that these are the same. It's that this one is congruent to this guy up here. So the two arc.
It kind of looked like that.
Because it melded with the right angle. So because of that, we were then able to do, we didn't actually need that part for proving the overlapping, but if you use that, you would have had other methods you could have done there. I think that one was perhaps the most intense there. And I apologize for number 4. Right now, again, without knowing isosceles base angles theorem, you didn't have a second way, you only had one way. But a reminder, always check both the bow tie and the big overlap. Draw those overlaps out.
I hate these overlaps, it's just so bad.
The overlaps are good for
I
you.
really don't mess with this word. I don't mess with
I feel like 5 was a big letdown. I thought something exciting was going to happen. And 8 was also let down. Not enough info all around there. Do we have questions on that front side?
Oh yeah, we were saying 5 about it.
Yes.
We usually need isosceles theorem.
Yes.
Okay.
But since we didn't know it yet, so I actually have a key where I accidentally used isosceles base angles thing. So since you didn't know it yet, then I tried to not use it.
Okay, because I'm doing
But yeah, you could do a lot more once you have that.
okay.
All right, and then let's go. Did you have a question, Kim?
Yeah, number 5 was out here again. Number 5 was like in my neck last night. I was like,
All I don't know that I understand a single thing you said. Number 5 was what?
Number 5 was tricky.
Okay. Cam, in your presence, I feel so much older.
Sorry, I'll keep old.
All right. So we've got 9 and 10 here. Not a whole lot.
What was 8? What was 8?
8 was not enough info for both the bow tie and the overlap.
The bow tie wasn't.
So you can see number 8 and number 1 are very similar, except they gave different information. So just because you have bow tie overlapping doesn't automatically mean they're all going to be congruent. It depends on what information they give you. All right. Now numbers 11 and 12, it's the same picture, but different information. Keep in mind, once you can prove, so I have my bow tie and I have my overlap. Once you can prove your bow tie is congruent, then fill in all those pieces, the 3 sets of angles, 3 sets of sides, and see if that's enough to get you your overlap. So for number 11, once I had my bow ties were congruent, and I filled in my pieces by CPCTC, then I did have enough for the overlap. And again, I feel like the easiest one for that overlap, just saying that the long legs add up to be the same, so side, side, side.
What was 12 about?
So they're asking about RTU, those overlaps there. So again, we first look at our bow ties, and our bow ties end up being congruent. So then fill in all your pieces, and then we have enough information for that overlap. The remaining thing is we have our reflexive property. We have a reflexive property down here. And then the long legs add up to be the same thing, a 3 mark and a 2 mark, a 2 mark.
How do we know that RQ and QS is?
RQ and QS. So we know that these bow tie triangles are the same by side, angle, side, side, angle, side. So once I have that, then I went back and filled in the pieces. Yes, Julie?
So if it doesn't ask you, do you have to do both, like the ways to solve for it, or can you do one and be right?
Oh, like side, 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 or side, angle, side? You only ever have to put one. Just put one. But I'm listing all the possible ways. And then these guys down here. Hopefully you caught for number 16 that what was wrong here was that the order of the letters was incorrect. So that statement here is incorrect. The correct statement was this.
Who's trying to go to? Alright, that's the one time.
Is it?
That's the one I had to. That's an iconic triangle right there.
You
Okay.
wrote it out as J.
And then number 17, we actually had that all 4 sets of triangles here were congruent. And so that was by side, angle, side, because they gave us midpoint and they gave us the perpendicular. But if you go back through, so that's these guys here. If you go back through and fill in your CPCTC, we can actually show that this top triangle ABC is congruent to this bottom triangle AFC. And then the left triangle ABF is congruent to the right triangle CBF. So hopefully you caught that those 4 little ones were congruent. But if you fill in your CPCTC, you can get a lot more.
What is that in the CBC?
Once we have triangles are congruent, then that means that the parts are congruent.
I'm not really just wing it to start out. I feel unconfident about this.
All right. Other questions with that?
I feel confident about that last text. I cannot
Okay.
look at it.
So we'll then transition to our quiz. And then again, once we come back from lunch, we'll pick up with our notes. No. We don't have proofs until next
Let's
week.
go! That's the worst.
I don't think that's true.
Okay.
That's a pretty good definition.
No, I think it's just
All right.
So everyone should have this in front of them. You should have picked this up when you took your quiz. So we've already briefly talked about this, but we haven't formally stated what these theorems are. So today, we get to formally state it and use them. So first of all, a reminder, what is an isosceles triangle?
2 angles equal. 2 sides.
2 sides are equal, but the definition is even pickier than that. At least 2 sides are congruent. Alright, so at least two sides are congruent. So like we talked about before, what does that mean for an equilateral triangle?
It's all
It's also isosceles because all of them are congruent. That beats the at least two. Now, again, we want to go as specific as possible. So if it is an equilateral triangle, we call it equilateral rather than isosceles, but just know it is also isosceles. Alright, so our isosceles base angles theorem, this is specifically for isosceles triangles. But our isosceles base angles theorem, we start off knowing it's an isosceles triangle, which again, to the sides are congruent. What we get from here is that we have the opposite angles are also congruent. So in an isosceles triangle, isosceles, the angles opposite the congruent sides are congruent. So in an isosceles triangle, the angles opposite the congruent sides are congruent. Now this is our normal regular isosceles base angles theorem. We start off with the sides congruent, which comes from simply the fact that it's an isosceles triangle. Then we can immediately know that angles opposite are congruent. So starting off here, we are given that BC is congruent to BA. Then we can say angle A and angle C are congruent.
That makes sense.
Well, good.
That makes
Again, we've already talked about this in relationship with our previous unit, where we know that if the angles are the same, the sides opposite are the same, the sides are the same, the angles opposite are the same, going back to our small, medium, large angles. But now it's formally stated for you in a nice, beautiful thing. Okay, do we have questions on that? All right, so the converse. So think back to Unit 2. If we have our conditional statement P implies Q, what did the converse do? Q implies P. Good. We had it switch. Which one negated it?
Inverse.
Inverse. Good. Great. So our converse, we're switching it. So all that we have happening here is we started off in our original theorem. We had the sides opposite. Our conclusion was, our sides congruent. Our conclusion was the angles are congruent. So our converse, we go opposite. We start off with our angles congruent, then we can say the sides are congruent. So again, pretty common sense, but it's important to note that the converse is true, because the converse is not always true. So in a triangle, if two angles are congruent, in a triangle, if two angles are congruent, then the sides opposite are congruent. In a triangle, if two angles are congruent, then the sides opposite are congruent. Okay, so again, it's just the reversal of it. So for the converse, we start off, they gave us that angle C is congruent to angle A. So our conclusion then is the side opposite is going to be congruent. So our conclusion then is that BC is congruent to AB. Now again, make sure you take note of the specifics. Our theorem is talking about that the angles are congruent, sides congruent. We're not talking about measures equal, but that the pieces are congruent. Okay, so our original, you know this smart word. Our original theorem says we know the sides, we can conclude the angles. Our converse says we start off with angles, we can conclude the sides. So just think back to our original theorem uses the fact that it is isosceles. Isosceles is defined by those sides being congruent. So the converse then flips that around. Okay, now we do have a corollary here. I think this is the first time we've encountered a corollary. And a corollary is basically kind of like a sub-bullet point of a theorem. So it's kind of a following thought from the theorem. So it's pretty much we have a theorem, and also this is true. So corollary, again, just like theorems and postulates, if there's not a name, we have to write out the whole thing. Corollary is not the name. It's a type of theorem postulate. So if we use this in a proof, you do have to write it out. But it's something that we've already discussed, something that we've already known. But a triangle is equilateral if and only if it is equal angular. What does it mean to be equilateral? Say it again, Henry. Good, our sides are congruent. What do you guys think it means if it's equal angular? All the angles are congruent. Good. Alright, now I'm going to make you think back to Unit 2 once again. What do we call this when it's an if and only if statement? Biconditional, beautiful. What's the notation for that? True, sorry. When we write it out in like this type of format, what do we draw instead? Gabe?
IFS.
True. I agree.
An arrow.
Yeah, we've got that double arrow. You're right, it's the if and only if, but we draw with that double arrow. So biconditional means it's true both ways. So if I have a triangle with all angles congruent, that's equiangular. I can know it's equilateral. If I have a triangle with all sides congruent, equilateral, I can know it's equiangular. Again, something we've already discussed. Alright, we don't use this one very often in proofs, but we will definitely be using isosceles space angles theorem and converse in proofs. And next class will be our proof. So make sure you do know which one is original, which one's converse. Alright, let's just go ahead and apply it for right now. So they ask for the value of x. Again, here we can see we have these congruent sides. So that means that the angles opposite are congruent. So if angle D is x, what can we say about angle F?
Angle F is x.
Angle F is x as well. Okay. So then how in the world am I supposed to solve for the value of x? Go ahead, Adam.
2x equals 150.
Tell me how you got the 150.
2x plus 3 equals 180.
Good. Remember our triangle angle sum theorem from 2 classes ago. All the angles add up to be 180 degrees. Subtract away your 30, we get 2x is 50. And what's our glorious x?
2x is 150.
Oh, thank you, sorry, 150, that makes a big difference. Now what's our glorious x? 75. So again, each of those angles, angle D and F, be 75 degrees. Now again, always make sure you have actually answered the directions. Did we take care of the directions? Did we follow directions? Yeah, they just simply asked for x, they didn't ask us to plug it back in. Alright, I want you guys to try B. And 42 is referring to this angle here. X is referring to just this piece here. You can either try this individually or with your solar partner. Or try first by yourself, or try with your partner. 42 is angle L. X is O and N. Keep in mind what you know about isosceles triangles and what you know just on the individual triangle. Once you get your answer, you check with someone nearby you. So that's because I think
How are we supposed to say it? You get 69. I don't do it. How are we? You get 69. You're stupid.
okay, so we can and they told us that and then they're
That's not. I got 69.
Wait.
Okay, so I'm seeing the same two different answers. So let's see if we can figure out what the misconception is. Do I know? Let me zoom in a little bit here.
Oh, I can't.
You don't even
do
have to
that.
ask. You can't say no.
I can't. Uh-oh.
I know you're.
Yeah, I realized because I can't. I don't know.
Alright.
Wait,
Do I know?
42 and 42.
That's 90 degrees.
No.
It definitely is.
You don't know that though. You don't know.
Definitely is.
Henry, why is it? So again, don't assume what the picture looks like, only the information given to you. So be careful you're not assuming information. But I did see that most of us at least had this. We had it's an isosceles triangle. So if this guy's 42, how much is this guy? 42. Awesome. And then they showed us that these two angles down here were x, so how much is this angle here? X as well. Okay. So for those of you that tried using just one part of your triangle, we didn't have enough information, we don't know that, so we can't solve for x, there's two unknowns. So instead, let's use the big triangle.
X equals 96.
Would you sit on my?
Alright, how many degrees are there in a triangle?
180.
180. So we got 42, 42, x and x. So it's 2x plus equals 180. This should be our setup. What do we get for our answer?
X equals
48.
48.
And so if you got, I think, 96, you forgot those 2x instead of x. Alright. Questions with that one? Alright, take a look at the back side.
You said tricky this one, right?
These are not tricky.
This first one is very tricky. This is tricky.
This one? Okay.
Oh, never mind. I thought you were talking about
We got the same answer.
Yeah.
Yeah.
We assumed that this was the right angle, but we got the same answer.
So you're lucky, because it ends up that it is the right angle. But we don't always have that. So you're fortunate, but don't assume. Okay. Finally, time to do a proof. Okay, so they gave us A, E, and D, E are congruent. They marked that in. A, B is congruent to D, C. They want us to prove.
Do we have to write all like the given stuff again?
Yeah, we're back to two common proofs. Would you say can we get cake and not do proofs?
Yeah.
I would rather
Sounds like a
cake
good day.
with proofs. Alright, so they want us to prove that EB and EC are congruent. Okay. What are you guys' thoughts?
Well, the first step is given.
Okay, I'll take that.
Yeah.
Okay, let's go.
Always write your given. Please don't forget this and lose easy points. What else do we do?
We know that
A,
AB
C are the
is
same.
congruent to CD.
Say it again.
AB is congruent to CD.
Yeah, that was part of
That was
our.
given.
That's part of our given.
Nice.
What did you say?
E and C are angle B and C are congruent
How do you know that?
because AE and ED are congruent. So from that.
So you've got the right line of thinking. You're just missing. You're messing up the part of what's congruent. So Cam's right. We've got in this triangle here. Since these are congruent, we've got an isosceles triangle, right?
Yeah.
So it's opposite angle. So
What
this is not part of the big triangle, so it'd be angle D and angle A are congruent. Does that make sense?
Yes.
Okay, I'll take that. Angle A is congruent to angle D. What's our reasoning for that?
Isosceles base.
Okay, we start off with our sides, so it's just normal. Isosceles, base, angles here. Yay, we get a timer for it. Got it?
I don't know if this helps, but AC is congruent to DD.
How do you know that?
Because if you like take the triangle apart,
Keep going. What do you mean by take the triangle apart?
like make the triangle AC and BE.
Good. So Adam's looking at these overlapping triangles here, AEC and BEC. Would you guys agree they share BC? So we could go down the road of segment addition postulate and show that this plus this equals this plus this, and that is true. Sometimes we have to do that, but for here, it's easier than that.
Can we do side angles now?
What? Side angle side, side angle side? Let's take a look at these little triangles here.
No
I mean, what we learned we have to use again. So would you agree that triangle AEB is congruent to, what would that be, DEC? Triangle DEC, don't forget your triangle. And as Elise said,
Do we lose points if you
Oh yeah. Yes.
Did you ever put that little triangle?
That's stupid.
that would be by side angle side. Awesome. So now that I have the triangles are congruent, now can we say EB and EC are the same?
Yes.
Yes. Why?
Congruent parts of congruent triangles are congruent.
Good.
People in the room
Looks like
so fun.
average.
CPC.
Yeah, I didn't know someone had to work their way through.
I didn't know they were in the
Yeah,
room.
who was that?
People are coming around observing people today. Like, I have to go observe someone after this.
I was like sweating. I was like, let me actually,
Oh, it's awesome.
let me actually try and do some geometry.
Thank you for using the geometry. Okay, so what Gabe said, we can indeed say,
It's the little triangle.
They were just kind of like being sneaky back there.
That party's gonna be doing.
They probably
Yeah.
said
I should have had you like sit right next to them.
Nah, I mean, I can
Start a conversation.
I'm just, it's been a boring day, Sean.
You could have pointed out how bad you did that.
Alright, EB is congruent to EC. Now, Gabe had the punchline for this.
Yeah.
Now that I have triangles are congruent, now I can say all their pieces are congruent. So once I've established triangles congruent, then I can say any of those pieces. And that is our very exciting CPCTC.
Yeah, so what that means?
3 C's with the physical therapist.
congruent parts of triangles
Corresponding parts of congruent triangles are congruent. So it's saying we have congruent triangles, awesome. Once you have that, then our corresponding pieces are the same. So then any of those matching up sides are the same. So it's actually 4 steps.
I can only tell this about me so long.
Yeah,
It's only 4 steps.
but like,
But we did have to first prove triangles were congruent before we could use those pieces.
It's like sometimes like you're like, how do I know I'm supposed to do that? Yeah. I'm just like,
Well, there's only so many options of what we can do. You caught the overall triangles isosceles, but I had to somehow tie in EB and EC. So I either had to use this individual triangle or the 2 triangles that contained it.
That's what I'm saying. It's kind of, it's not like a clear answer always.
You definitely have to think about what tools you have and what would apply here.
Yeah, I just like solve for X. I really like that. That's my thing.
Well, look at number 5.
Oh yeah, let's go. And Y.
Okay, so we have questions on our proof. Okay. So now down here are just some examples of using the fact that isosceles triangles, the opposite angles are congruent, and equilateral triangles, all the angles are congruent. Yeah, let's do number 5.
I already know what it is.
I already did it.
All right. So number 5.
Yeah.
Well, we know that 115 equals x plus y, right? That's our exterior angle theorem.
Yeah.
But that's one equation, 2 variables.
I'll
So
solve some mean X and Y.
what else do we? What else do we?
Well,
We know that those sides are
We know these sides are congruent, so our angles are congruent. And Henry said we can find this blank angle. How do we find that?
Subtract 1.
The 115 and the blank are linear pairs of supplementary. So 180 minus 115, 65. So then we have x equals.
Oh, that's. Wait, how do
That's supposed to be 65.
How do you know that?
for Sean's enthusiastic.
X in the other angle, is it because of that sausage base thing?
Yeah, they do that.
Yeah.
That's
So isosceles base equals there, so let's begin. So we have x equals 65. Plug that in, solve for y, what do we get?
Why?
Y equals 50. Okay, question to that one. I want to do, I think I want to do number 1 down here. Because they gave us these beautiful overlapping triangles. So,
Lost over here. Lost. Which one is it?
number 1.
Number 1. Lost and learn. Okay.
I got it.
All right,
And it's
Nathan,
45.
how'd you do?
No, I think I got this.
No, because look.
Can't believe it
look.
was 45, other than talking
No,
about
no. I can prove it though. I can prove
Okay,
it.
good.
So
Explain.
one of them is 90, right?
Good.
Right. So that's 90. 45 plus 45 equals 180. Oh, equals 90 plus 90. 180, baby. Let's go.
Good. So we have this triangle here. It's a right triangle. So that allows us to find our end. There's 45 there. Nathan, you want to take us the rest of the way?
Yeah, I got it. So,
No. N equals 15.
How do you know that?
Because of the,
if any one is
because it does.
yeah, but how?
Yes, Adam.
Because the triangle's in an equilateral triangle, and so.
This guy always gets it.
That's such good explanation.
No, it's 60. You do that.
Good. So it's equilateral because all the sides. Well, how did we know that all the sides were the same?
I just had a hitch.
We technically didn't know that all the sides are the same, but it's isosceles, which means these have to be congruent. And so if 60 was already taken, there's 120 left, which means these must be 60 as well. Okay. So we have n plus n equals 60. Throw in your 45, and we get n equals 50.
I can do the next one.
Great. Take us away.
Alright.
Listen here, dude. So, I got it.
M equals 44.
Okay, can you give me some explanation?
Because you do the 66 on the other side.
How do we know?
It's 68.
68.
How do we know that's also 60?
68.
Because of the base, isosceles base angle.
The isosceles base angle theorem says these are congruent,
And then we solve for the top part,
which is
44.
good.
And then
it's
vertical
vertical
angles.
So vertical angles n is 44.
And then you do the same thing.
And is also 68. Same triangle.
Good. So we have, again, 180 degrees, subtract away 44. What's left over, divide by 2 to get your n. And we have,
I got these on the next one. This one looks scary though. Like, this is even a triangle. What is this? It looks like teeth. Look at it like that. Looks like some like choppers.
Some pretty angry.
Yeah, that's some teeth right there.
all right. So for number 3 here, it is a little more complex, but it's just a series of isosceles after isosceles after isosceles.
Oh my.
So if I have this as 15 degrees, how do I find these two angles?
Alright, well,
down
they're
here?
going to be equal, so it would be 2x equals, 2x plus 15 equals 180.
Good. Go and solve for x for me.
Oh no. Wow. What is it?
What is it?
82.45. That's what I thought. I was like, 45.
We do get decimals for this one.
Yeah, so
Is it 82.5?
Yeah. So x. Well, and I guess we said. Oh no, x.
So that's gonna be this guy here, right? Okay.
Skip to worksheets that roughness. Equal 5 and 6.
Just go with it. We did 4. 5's coming later. If this was 15, how much is left over here?
I don't know.
75.
Oh,
75
that's
because it's 90. That's what?
facts.
Try hard.
Again, we have isosceles, so this is also 75. So how can I find my remaining amount?
Yeah, they can just kind of try our numbers.
I'm not done yet. I'm almost done with
Repeating.
30? Awesome. Thank you. Add up, subtract from 180. And then now we have these all add to be 180. So after 30 or 80.5, subtract 180. And then last but not least, because this is isosceles,
Also, I can biology.
and we have these are congruent. And again, subtract what you know from 180, divide by 2.
I'm ready for biology. I have 99.
Wait, yeah, sorry.
All right, have a good weekend. Make sure you got your homework worksheet 7.
Come see me on the court, one-on-one. I have to go. All right, let's go. Hey, I gave you the note.